Okay, hello Matrix. Today we're going to be doing the mechanical analytical question for the study pack, and let's just get started. So we've been given the front and top view of a wrench and a isometric drawing of the wrench as well, a little isometric SketchUp, a title block and a table of questions, and the drawing is not presented to the indicated scale. Okay, so it says complete the table below by neatly answering the questions which refer to the accompanying drawing, title block, and mechanical content. Okay, so we've obviously got our questions here, our drawing here, and part of our title block over there. So it says who checked the drawing. So we're going to have a look and we're going to see checked by Jerry. So we will write Jerry. Then it says, what is the roughness value? Now this is something you should know based off of your studies, where to look, and the roughness value will be 0.4. So you are going to write 0.4. Okay, then it says, what is the measurement at 1? We're going to look at 1 over here. Now you can see 1 is pointing to this inner circle over here, and because we do not have that measurement given to us, if you have a look around, you won't see the measurement for any of the circles here specifically. We know that we will have to look at this here, where it says all unspecified radii are 2 millimeters. And so we know that the measurement 1 is 2 millimeters. Okay. Then it says, what does the abbreviation PCD stand for? Now, PCD is something that you should be aware of. It should be something that you've studied. And PCD stands for pitch, circle, diameter. Okay, pitch, circle, diameter. Then it says how many wrenches are being manufactured. And if you have a look here, you'll see quantity 15. And so 15 wrenches are being manufactured. Then it says here, what is view 1 called? Now we know based off of the drawing that because this is obviously a mechanical question, we are working in third orthographic projection, which means that we have top and front. So view 1 would be our top view. So we would write top view. Okay. Then it says if a scale of 1 to 4 were used, what would 2 be? So we look at the measurements of 2. It's got a diameter of 3. Obviously, we know that this means it would be 4 times smaller. So we would say 3 divided by 4, which would give us 0.75. So we would say a diameter of 0.75 would be used. Okay. What is the drawing number? So we are going to have a look here, drawing number 13. So you'll say no 13. Okay, name the section at 3. So you'll see 3 is pointing to a little piece over here. And because it's not a full section, it's just a little, like a little small little section that has been sectioned. It is called a part section. So we will write part section. Okay, then it says complete the dimensions at 4, 5, and 6. So we are going to have a look firstly at 4, which will be this point here. Now we obviously are going to have to work this out, and the reason why is because if we have a look here, we haven't been given the measurements for this here. We have been given sorry guys, the cat's just busy driving me mad here. I don't know what he's doing. Okay, so obviously we have not been given that measurement. We've been given a measurement here of 1, but it's best not to assume what the measurement would be, so we're going to work it out. So here we've been given a full measurement of 8 and 5, so we're going to say 8 minus 5, which will give us 3, divided by 2, which will give us 1.5. So we will say 1.5 millimeters for 0.4. Okay, and as you can see, it's not the same as 1. Okay, Then it says, obviously we need to determine the measurement at 5 as well. So we're going to see 5 over here. Now this one is in the middle of the wrench over here, and we've been given a measurement here, 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 and obviously this measurement over here as well. So we are going to use this to kind of help us determine what it is. So we've got 17 minus, then we've got 6 at this point here. So we'll say 6 minus 4, which lines up here, minus 4, which is the edge over here. And that will give us a measurement of 3 millimeters. Okay, then we've got number 6 that we need to determine a measurement for. And you can see it's got these little gaps here. So we've been given a measurement of 10, 3, 2, and we are obviously going to need to determine the radius over here to get the full measurement, because obviously if we have 10 minus 3 minus 2, we get a measurement of 5, but it does not include the circular bit. So we know firstly that we have a radius here of 2, because obviously all unspecified radii are 2, so we're going to say minus 2. And then we know that it's got a thickness of 1, so we're going to say minus 1, which will give us a total of 2 for that little section there. So that will then become 2 millimeters. Okay, what is AutoCAD 2024? And the answer will be that is the drawing program. So you are going to write drawing program. Okay, then it says here, what is the total length of the wrench? We're obviously going to have to work that out. So we can start off, we've got 72, okay, and we have got 10, 26, 17, 19. So let's start by adding from this way. To me, that would make the most sense. So we have got 17, then we move on, we've got 19. Then if we have a look here, this full length here is 26, so we're going to say plus 26. Then we have got here a measurement of 10, which is obviously from this bit here, so we're going to say plus 10. Then we have obviously got 72 from this point onwards, so we're going to say plus 72. Okay, but again, we've got the circle here that we need to account for. So we've obviously got the unspecified radii, which will be 2, so we're going to say plus 2. And then we've obviously got 1.5 for the edge over here, so we'll say plus 1.5. And that will give us a full length of 147.5. Okay, millimeters. All right, then it says measure the angle at 7. So if you have a look here, we've been given an angle over here. So there are 2 ways to work it out. You could obviously use your protractor if that is what you would like to do. But if you are more mathematically inclined and you'd rather use it a different way, which I'm going to use, there you can do angles around a point, which we obviously know a full rotation will be 360 degrees. So we'll have 360 degrees minus this here would be 90 degrees. Sorry, what am I saying? First, we're going to minus the 125 degrees. Okay. Then we are going to minus this here, which is 90 degrees. Obviously, just make sure with your ruler beforehand. But yeah, it is 90 degrees. So we're going to say minus 90 degrees, which leaves us with 145 degrees. Okay. Then it says, when was the drawing approved? So we're going to see approved by, then we get the date. So we're going to say 2024 of the 7th of the 04. Okay. How many surfaces are machined? Now this one is very important for you guys to make sure you know what this means. So we know that this machining symbol over here shows that this top side needs to be machined, so that will be 1. Then we have got 2, 3, 4, but that is not a complete answer because the top here would be 1. Then we've got 1 here, but that means that this side here would also need to be machined, and that's something that we can assume. So it'll be 1, 2, 3. Same with this side here, 4, 5, 6. Okay, 6, and the bottom here, which would be 7 as well. So we are going to say 7 sides need, or surfaces need to be machined. Okay, then it says what is the drawing title, and if we have a look here, the title is P12 wrench, so you can just write P12 wrench. Okay, what is the production method used? So we're going to have a look here, and you can see the production method is machined, so we are going to write machined. Okay, and then it says with reference to the tolerance, what is the max and minimum dimension for 8? So we're going to find number 8 first, which is here, it points to obviously 0.7. So the max would be plus 0.2, so we would have 7.02, and the minimum would be minus 0.17, so we would have 7 minus 0.17, which would give us 6.83. Okay, then it says draw in neat freehand the orthographic projection symbol used in this drawing according to Sans. Okay, so that's obviously answer 19. Now, because we know that this is third orthographic projection, our projection symbol will be a circle followed by another circle. Just make sure yours is done neatly in freehand, followed by this over here. Okay, and then it says draw a neat freehand the graphic convention for spur gear according to Sans. Okay, so this one's going to be a little bit more tricky. This is obviously something you would have had to have studied in order to know what that is. So let's just do it together. We're going to start off with a little circle here and like a little keyhole. Okay, then we have got a circle going around that. This over here. All right, and then we obviously have our center line. So we're going to do long line, short line, all the way through like that. Then we've obviously got the edge as well, which will be long line, short line, long line, short line, long line, short line, all the way around, just like this over here. But then we are not done. We still need to do the other side for it. So we will draw this in over here. Okay, we will obviously have a hole here and a hole here because obviously the spurs of the gear. So there will be a center line going through there and there. Okay, then we've obviously got a solid bit here and then the keyhole. So the solid bit we will then hatch. Okay, we've got the keyhole and then the normal hole, and then we will finish off our hatching again. Okay, so there we go. That is your mechanical question done. This one is relatively easy. We tried to make it easier to start just so that you get the hang of it, and then we're going to slowly make it so that it's a little bit more complicated as you go on. So let us know what you think so that obviously we know how to improve and things like that for the future. But yeah, thank you for watching.